Good evening, everyone. This is Catherine reporting live from West Lafayette with our headline story, The Chemistry Behind Preservatives and How They Keep Food Fresh. For as long as humanity has existed, food survival has been important. But how did we keep food fresh? Long, long ago, humans used methods such as sun drying. For example, ancient Roman civilization and ancient Egyptians stored items such as herbs, spices, meats, fruits, and vegetables by using various food-preserving techniques such as sun drying. A major turning point in the history of food preservation occurred in the 1800s. At that time, soldiers were away for long periods of time, and they frequently had to deal with spoiled meats, which was nasty. Definitely not a meal to look forward to. Salt was the best preservative at that time, so leave it to the one and only Napoleon Bonaparte to pay lots of money for people to discover ways of better preserving food. Ultimately, the French chemist named Nicolas Appert discovered that storing food in an airtight container would prevent food from spoiling and rotting. Half a century later, a person named Louis Pasteur had an experiment that overturned the popular myth of that time, that germs spontaneously appear in foods. Pasteur's experiment proved that food, in his case broth, does not spoil in a closed container if heat is applied to kill any bacteria. He demonstrated this by adding broth to 2 flasks, as pictured on the screen, and storing them at room temperature while occasionally applying heat to kill any germs. Weeks later, he noticed the S-shaped flask had the same consistency as at the start of the experiment, while the open-topped flask was cloudy and had lots of indications of contamination, which meant that it contained bacteria. Pasteur hypothesized that bacteria had entered the open-top flask, while the S-shaped flask prevented germs from contaminating the broth, because it prevented them from entering the flask. And now to Maya, who's live on the scene.
Thank you, Catherine. It is fascinating, isn't it? Now, according to Dehydrator blog, this breakthrough discovery led to various preservation methods such as canning, drying, dehydrating, freeze-drying, smoking, pasteurization, and irradiation, as well as addition of chemical additives. Food preservation has become an important part of the food industry and our daily lives. Below is a timeline where we can see how food preservation has evolved throughout our history. Around 500,000 BC, our ancestors first started fire cooking food to make sure that it wasn't rotten. At 12,000 BC, we started sun drying. 600 AD, there was jam preparation. 1400 AD was refrigeration. 1809, we had canning, and so on. Today, we have chemical preservatives. And today, the most common methods of food preservation are freezing to slow the effect of bacteria, drying to reduce moisture, boiling to eliminate bacteria altogether, and pickling and salting. Now, the most popular food preservatives today are chemicals. These chemicals include sodium benzoate, sodium sulfite, sodium nitrite, butylated hydroxyanisole, butylated hydroxytoluene, and other chemicals. Oftentimes, these chemicals are added in small concentrations to food to inhibit bacterial growth and prevent odors in foods. When coupled with methods of food preservation, these chemicals work to keep our food fresh longer than ever. And now over to the expert in our field, Dr. Legate.
Thanks, Amaya. Antioxidants are also really good chemical preservatives because they prevent free radicals from ruining the food. Free radicals are dangerous to food because they are extremely reactive. They often lead to the oxidation of some chemicals in food, making them super unsafe to eat. Antioxidants react with the free radicals, removing them from the food and not allowing it to spoil. So here you can see ascorbic acid, also known as vitamin C. So it's really good for your body in a lot of other ways. And it's natural, and it reacts with O2 radical and creates dehydrized ascorbic acid. So as you can see, we broke this double bond in the middle and created bonds here and lost a couple H's. And then along the way, with those H's also bonded with the O2s just to make some water. And we double bonded these O's. So this was an oxidation process from the ascorbic acid to dehydrized ascorbic acid. So now on to Nate with another good mechanism.
Thank you, Ryan. Now let's talk about sodium benzate. This is an antifungal preservative that prevents the growth of mold in beverages, fruit-based preserves, meats, and a variety of other foods. It works by forming benzoic acid as a result of lowering the pH in the food or beverage to create an environment in which microorganisms cannot thrive.
So when you're making a soda or a beverage, basically the acidity will be heightened within the food, and all these H plus ions will appear. Thus, the sodium benzate will grab this hydrogen, and it will form the product that actually preserves the beverage and limits the growth of yeast. So this becomes
Benzoic acid. This preservative is widely used in sodas, both to work as a preservative, like such, and also because the higher acidity enhances the flavor of the high fructose corn syrup used in most beverages. Benzoic acid has been pronounced safe to ingest by the EU. Now, on to Catherine for a talk about safety.
Thank you, Nate, for describing our example, sodium benzoate. So now, as for the safety of preservatives, nevertheless, although most preservatives are now considered to be without potential adverse effects and are classified as GRAS, there have been problems concerning the safety of some of these chemicals, including the possibility of allergies from, for example, benzoic acid and some sulfites, the formation of carcinogenic nitroamines from nitrites, and the possible rodent carcinogenicity of BHA and BHT. Despite this, it's important for the general public to know that the FDA, Food and Drug Administration, will basically approve of any preservatives that are used commercially to ensure that everyone knows that they are safe for the public to buy. And also, something to keep in mind is that if you have any allergies and you're aware of them, you'll want to be sure to avoid purchasing and consuming foods that contain preservatives that might make you sick because of your allergies. And now we'll send it back over to Nate for him to tell a personal experience of the powerful impact that preservatives can have on the general public.
over the summer last year, I worked in a soda bottling facility. One of the requirements for all beverages leaving the facility is that they have a very specific pH level. If this level is off, the drinks must be thrown away, since pH is extremely important to get right. The leading reason for this is that off-spec pH can be unsafe to consume, which is of course the top interest for a drink or food provider. Secondly, the pH has a drastic effect on the taste. Even if it is off by just a little bit, the consumer might be able to tell, which gives the company a lot of bad rep. One day while I was working in this facility, it was discovered that a batch of diet soda had been shipped out with incorrect pH levels. What ensued was a wild search through filing cabinets to quickly locate where every last can of soda had gone to. Once it was all accounted for, it was all recalled to the facility to be thrown out. This small mistake nearly caused a very large incident, and precautions were taken to limit the risk of this incident happening again. pH can be very important in all food and drink to get right, because the public is the top priority for companies to protect.
Thanks.